What we're talking about today is lesson 77, using the law of cosines. For a triangle that is not a right triangle, the law of sines can sometimes be used to find a missing measure. It can be used when given two angle measures and a side length, or two side lengths and a non-included angle measure. The law of cosines can be used other times, specifically when the measures of two sides and the included angle are known, which is side angle side, or we say SAS. The measure of all three sides of a triangle are known, which is side side side, or SSS. To derive the law of cosines, let H be the altitude and AD equal X in triangle ABC shown at the right. Then DB is equal to C minus X. In triangle ABC, B squared equals X squared plus H squared, and cosine of A equals X over B, or X equals B cosine A. So what we're going to do here is we're going to talk about how they come up with this formula for you. Okay, so it wants us to write the equation that relates the sides of triangle DCB. So triangle DCB are right here. Okay, and what they have written is that A squared, which is our hypotenuse, this is an A over here, A squared is equal to the two legs being squared. So this is one leg squaring it, this is the other leg, and they're squaring it. So that's where they've gotten this from. They've written it out as a Pythagorean theorem because this is a right triangle. Then to get from here to here, they square the binomial. So they rewrote this as C minus X times C minus X, and they come up with this, and they just brought their H squared straight down. It's still equal to A squared. Then they said that we could substitute B squared for X squared plus H squared, because B squared, this would be B squared right here if we were using this this right triangle on this side. Okay, because this is A, B, and C for the Pythagorean theorem, so B squared is equal to those two sides squared. That's how they are able to substitute B squared instead of that X plus H squared. Then it says to substitute B cosine A for X. That is what they talked about up above. Okay, and then all they did was rearrange things. So we wrote it as B squared plus C squared minus 2CB cosine of A, and then again they just rewrote it using the commutative property of multiplication. So that means that A squared is equal to B squared plus C squared minus 2BC cosine A. Okay, you can remember that if you're looking for A, then it's going to be BC minus 2BC cosine A. Okay, so on the next slide we have the law of cosines. Okay, it works just like the law of sines, they just move things around the same way. Okay, so we just said if you're looking for A squared, then you have BC and then 2BC cosine A. If you're looking for B squared, then instead you would have AC, 2AC cosine B, and for C squared, we have A squared plus B squared minus 2AB cosine C. Okay? So, it says find the unknown side of the triangle, and it wants us to solve the triangle. Okay? So, whenever we're solving a triangle, remember we're looking for every missing measure of that triangle. So, the first one we're going to look for is that side length S. Okay? And we're going to use the law of cosines that we just talked about to do that, because this this one, okay, we're going to say if we're looking for S squared, because that is what we're looking for, that would be equal to R squared plus T squared minus 2RT and then cosine of what it is that we're looking for, which is S. Okay, so I can just plug in the information that I have now. So S squared is what I'm looking for, equals R. R, okay, side R is opposite of angle R, so we have 17, which is being squared, plus T, okay, that's opposite of angle T, so that's 13. It's being squared, whoops, minus 2, and then 17 times 13. Cosine, whoops, cosine of S, which is 75 degrees. All we have to do with this is plug it into our calculator exactly the way that we see it, which is going to get us that S squared is equal to, go ahead and plug that in. Okay, you should get that it is approximately 343.6, but I don't want S squared, I just want S, so I need to square root both sides, which tells me that S squared is not S squared, tells me that S is approximately 18.5. Okay, so that's what this side length is. Okay, now that I have all my side lengths, I can go ahead and use my law of sines to help me find my missing angles. Okay, so I know that the sine of S over S is equal to the sine of R over R. So the sine of S, that is your 75 degree angle, over your side, which is 18.5, equals sine of R. We don't know what R is right now. That's what we're looking for. And then our side length for R was 17. So you can do your cross multiplying, simplify. You should be able to find that R is approximately, let's see, the measure of R is approximately 63 degrees. And once you know that, you should just be able to use your regular rules for triangles, knowing that those three angles have to add up to be 180. T equals 180. So that will help you to find that T is 42 degrees. Oops. So that's it. Final answer. Alright. On example 2, it says finding the unknown angle of a triangle. It wants us to find measure of angle C rounded to the nearest tenth. So we're looking for this right here, okay? And we have all of our sides. So we can still use our law of cosines to do this. We're looking for C, so we're going to use C squared here. C squared equals A squared plus B squared minus 2AB cosine of that angle that we don't know. Okay, so we can plug in everything that we do know. 21 square it equals A, which is opposite of the angle, is 12. Square it plus B, which is 18, and square it, minus 2 times 12 times 18 cosine of angle C, which we don't know. Okay, so then we can go ahead and do the math on that, which is going to give us 441 is equal to, whenever we square these and add them together, we're going to get 468 minus, multiply these, gets us 432 cosine of C. And then from there, all we have to do is solve, right? So I'm going to get C by itself. I'm going to subtract 468 from both sides. I get negative 27 equals negative 432 cosine of C. Then I'm going to divide by that negative 432 on both sides. Okay, so those will cancel out, and I'm left with 0.0625 equals cosine of C. And I hope that you remember to get rid of that cosine of C. We're going to use inverse cosine. So all I have to do is plug that into my calculator, inverse cosine of that 0.0625, and that will get me C, which is approximately 86 degrees. Okay, so make sure that this is what you're getting when you plug it into your calculator. Okay, but all you have to remember is what this formula is, plug it in, and then solve it. You guys can do that. Example B says in triangle DEF, D is 60, E is 48, F is 14. Find the measure of angle D, round to the nearest tenth. Okay, so whenever they tell you something like this, I always like to write it out because I am afraid, or not write it out, but draw a picture, label it, and then write it out because I'm always afraid I'm going to put something in the wrong place. So I know I'm talking about triangle DEF. I know that D is longer, E is not quite as long, and then F is short. So D is 60, E is 48, and F is 14. Okay, so if this is D, this is angle D. If this is E, this is angle E. And if this is F, then this is angle F. So I'm looking for the measure of angle D. I'm looking for this, which means that I'm going to use this 60 as my my a squared, c squared, whatever that I'm going to have this all equal to. So I have that I'm using d squared equals e squared plus f squared minus 2ef cosine of that angle that we're looking for, which is D. At this time, I would like for you to, on your own paper, work out the problem. So go ahead and pause the video now. Okay, so all you should have done at this point is plug and chug. So D is 60, so we plug it in, square it. E is 48, plug it in, square it. F is 14, minus 2. Instead of E, we're going to put 48. Instead of F, we're going to put 14. Cosine D. So then I get 100 equals 2500 minus 1344 cosine of D. Okay, so subtract this from both sides. That's a 5. And I get 1100 equals negative 1344 cosine D. Divide by that negative 1344 on both sides. So when I divide these, I get a negative 0.8185 equals cosine of D. And again, we're going to use that inverse cosine to find what that D is. 8185 equals D. D is equal to approximately 145 degrees. And that's our final answer. I hope that that is what you got. The area of a triangle can be determined when the three sides of the triangle are only measures given using Heron's formula. Okay. The law of cosines can be used to prove Heron's formula. This proof is left for more advanced mathematics courses. Okay. So basically what they're saying is don't worry about the proof, but here's the formula. So we're talking about finding the area. Okay. Area is equal to the square root of s times the quantity of s minus a, blah, 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 where s is equal to 1/2 a plus b plus c. Okay, so you find s first, plug that into those locations, and then you plug in your a, b, and c. Alright? Alright, so on example 3, it wants us to find the area of the triangle. Well, let's start by rewriting that formula. The area was equal to the square root of s times s minus a, s minus b, s minus c, and we know that s is equal to 1/2 a plus b plus c. Alright, so all we have to do is plug those in to find our s first. So a, we'll say 9, 11, and 18. So when I add those together, I'm going to get 1/2 of 38, and s will then equal 19. So I'm going to plug in my information now to the area formula. So I have a equals square root, I have 19, and then 19 minus 9, 19 minus 11, and 19 minus 18. Okay, so I'll simplify inside. oops, I have 19, this will give me 10, this will give me 8, and this will give me 1. When I multiply all of those, I get 1520, which is going to give me, whenever I square root it, approximately 39. And it doesn't say the units, so we're going to just say square units. So that's my final answer. Example 4. Hiker A leaves camp and hikes in a straight path for 3 miles at an angle of 30 degrees west of north. Okay, so first of all, you are going to have to be really careful when you're reading these problems because of things like the direction that they're heading, west of north. Whoops, let me just scratch that out. West of north. Okay, so the camp, we'll say, is right here. And we know that the hiker A leaves camp and hikes in a straight path for 3 miles at an angle of 30 degrees west of north. So north would be right here, right? But he's going 30 degrees west of north. So I hope that you all know your directions. North, east, south, and west. So he is actually over here. And I know that this distance is 3 miles. Okay? Hiker B leaves the same camp and hikes at a fairly straight path for 8 miles at an angle of 80 degrees east of north. Okay, so if this is north, 90 degrees east of there would be a straight line this way, right? So it's just going to be a little bit smaller. And we know that this hiker went 8 miles. If hiker A stays where he is and hiker B uses her GPS device to walk straight towards him, estimate the time it will take hiker B to reach hiker A if hiker B's average hiking rate is 2.75 miles per hour. So what we need to figure out is this distance, okay? And we know that distance is equal to rate times time, so we're going to use this rate to find the time, okay? So since I've been given two side lengths, I know that this is 30 degrees and this was 80 degrees. Okay, so the whole thing here is 110 degrees. Okay, let me double check my picture. I look good. Okay, so then all we have to do is plug in to solve for this side length. We want to know this side length, that distance. So we're going to just call it D, which would be a lowercase d because it's the side length. Okay, so we have D here. We'll call this A and this B, which should be capitalized because they're the angles. Alright, so since I'm looking for D, I'm going to have that D squared is equal to A squared plus B squared minus 2AC, or not AC, AB cosine of D. So all I have to do is plug in. I'm looking for D squared. I'm looking for D. A is 8, square it, plus B is 3, square it, minus 2, 8 times 3, and then cosine of angle D, which we said was 110 degrees. Okay? So what I would like for you to do is, on your own paper, I want you to figure out how long, that's the question, estimate the time that it's going to take her to hike from her location over to his location in a straight line. Okay? Pause the video now. Alright, so at this point we should be able to simplify everything on this side just by plugging it into our calculator. So you should plug it in, make sure you use parentheses, yada yada. Whenever you plug all of this into your calculator, you will get approximately 89.42. Okay, but I don't want D squared, so I have to square root both sides, which gives me roughly 9.5. Remember, this is the distance, 9.5 miles. We know that distance is equal to rate times time. If the distance is 9.5, then, and the rate they gave us was 2.75, we want to know her time t, divide by that 2.75 on both sides. Okay, so that will give us that t is equal to roughly 3.5 hours. Okay? And that's our final answer. I hope that you have taken good notes. You will have the rest of the hour to work on your assignment, which I didn't write down apparently. So your assignment is A through F, and we're going to do 1 through 10 today. Alright, so you have the rest of the time to work. The assignment will be due when you come into class tomorrow, and it will be graded as a group. Have a good rest of the day.